Welcome to this restoration of a Sharp MZ-80K home computer from Japan from 1978. It's a historically significant computer that I am restoring for the Dutch Home Computer Museum. And of course, the first thing I did was to dust it off a little bit so I could touch it. This is a very abused machine. The paint is coming off from the case. It's very dirty. It belonged to a compulsive modder that made all kinds of modifications. Those three extra buttons you saw there don't belong in this machine. The chassis is all bent, doesn't sit flat on the table. All of those connectors on the side that you see there don't belong in this machine. They are not original. You can see the chassis of the case of the monitor all bent up and banged up. Cracked, the little frame, the bezel on the front is cracked. All kinds of holes that the previous owner made. Also at the back of the machine, those three holes at the front, he added this volume control for the speaker, which is completely unnecessary. He put a hole on the back of the case. There is already volume control inside in another plate, so this guy was a serial modder, and I have to undo all the stuff he did because it's dangerous and unoriginal. We see a board there. I suspect very strongly that modification is for increased clock speed and for 80 columns video. There is a big backing EEPROM on top of the original kernel ROM. That's probably related to the 80 column modification as well. All kinds of wires. It is a mess. It's noodle soup. And I have to undo all that and fix this machine and put it in a state that it can be used without risk daily in a hands-on computer museum where people come to use this stuff. So I proceeded to remove all these extra buttons. I will close the holes in the case as well. Now, taking away the power supply, I'm basically disassembling the whole thing so I can restore it fully. So there goes the power supply. The case of the power supply also has some damage on the paint, which I'm going to restore and fix later on. This is going to be a full restoration. Again, because it's going to be in a hands-on computer museum where people will use it daily. So it's not enough to just fix the machine. I have to put it in a state in which it's not going to blow up immediately. So to remove those connectors at the back, those are the monitor and the tape deck connectors. I'm using some electronics detergent to make it easy to pull the connectors out because after, I don't know, 40 plus years, 44 years, those things are not easy to pry out anymore. But with a little detergent, eventually it will all come out. The first one was pretty stuck, so I started at the back. But everything was pulled out without any damage. You can see some of the extra wiring on the top case that go into the tape recorder. There is so many modifications in this machine. I didn't even keep track of everything that this guy did. So with the power supply out, I have to remove that board, and there is no other way to do that but to just go ahead and cut all of those wires. I'm not keeping that stuff anyway. So for now, I just want to physically remove the board before I clean it out properly. So I'm just cutting the wires at first. That board is a hazard. I'm going to show that to you. It's handmade with decalc, and the traces are way too close together, as you will see soon enough. There is solder and flux residue all over the place. There is absolutely no attention for impedance control, for signal integrity. That thing is a hazard. It's a short circuit waiting to happen. If it hasn't happened yet, which I suspect strongly it has. You see a little crystal there, so that's the higher clock speed 80 column modification, I suspect. I didn't bother to look into details, but look at that. Look at that homemade PCB. Look at how close the traces are, the angles, and it's a signal integrity and electronics hazard. This thing. I'll keep it just as a recollection of what people used to do, what a compulsive mother would do to this machine. So now we can see the rest of the main board a little bit better. That's the logic. Those are 74 series ICs. There is a ROM in there, an EEPROM. This computer is a 48K version, so you will see there 3 rows of 8 DRAM chips. It's 16 kilobytes per row. It's 1 bit per chip. That's why you have 8 chips. That's the kernel ROM, and there is an EEPROM piggybacking on it to extend the kernel, I think, to deal with the 80 columns mode. First thing I do is to remove that abomination from there. I'll do it very carefully because I want to save the original ROM chip underneath. I'm not sure that it's working, but I want to give it an honest try. Instead of just burning another EEPROM, I would try to keep the original. There it comes. There it comes out. I'm being very delicate not to damage anything beyond what has already been done. That's the piggybacking thing that I have to undo. And I did that, and that's the final result. I didn't show you the use of solder wick, but I'm going to do it again, and you will see how I go about it. So now I'm trying to remove the motherboard. A lot of wires cutting there. I'm going to cleanly desolder those wires shortly. For now, I just want to take the motherboard out so I can work on it without difficulty. I'd forgotten one little screw there before I can remove the motherboard. You can see those modification wires hanging from the top of the case, protruding out of the cassette deck. This was a mess. But anyway, here's the motherboard. It's finally out. And now we can have more or less an idea of how it looked originally. Although all of those bodge wires still hanging from the bottom, I have to desolder that stuff carefully. But this is more or less what the real thing, the original thing would look like. I'm removing now that reset button, and you might say, well, that's a very convenient button to have. There is already a hole made in the case for it. But yes, but this is going to a museum, so I really want it to be in original condition. If I keep the button, I will keep it inside the case, and I'll close the holes that were made in the case, so we have an original looking computer. Now this soldering all that noodle that the previous owner put in there, removing the bodge wires is easy. It's more difficult to close the traces that he cut. I will do that soon enough, but there you are. That's the motherboard, freed from most of that mess. But now the work is actually only beginning. So first of all, I put that cleaned up original ROM chip back in its socket after I've cleaned the socket. Don't know for sure it works, but I will give it a go. Keeping the original is also a good thing, always a good thing. And then I found that there are 2 extra SRAM chips piggybacking on the original. That's the video SRAM. And they were doubled because 80 column stacks, that's what I suppose. I don't know for sure, but it's got to be that. So I have to remove those extra chips as well. And I'm going to do that with a high quality solder wick with flux in it. It's a delicate job. You have to do it on the motherboard because I didn't want to solder the original chips underneath. And I also want to reuse the extra chips that were placed on top. I want to use them as reserve chips. So it takes quite a while to do this carefully, but with good solder wick, with a good soldering iron and the appropriate tip for the soldering iron. In this case, I'm using a 2.5 millimeter chisel soldering tip. I believe I'm using 460 degrees Celsius on the soldering iron. Doing that, we can remove the chip more or less cleanly. The first one comes off cleanly. And I try not to use a heat gun. I think hobbyists use heat guns too much. You don't desolder chips with a heat gun. It exposes the entire chip to high heat. You use a desoldering wick. It's much better. I used a lot. But yes, I must confess that sometimes you gotta use a heat gun. And in this case, for the second chip, I did need to use the heat gun. But for desoldering a chip from a motherboard, I never use a heat gun. I use a desoldering gun with a vacuum suction. And then whatever little bit of solder is left behind after that, I remove with this solder wick, but never with a heat gun, not to expose the chip to unnecessary heat. And after I removed the extra chips, the result is a mess without the flux. But I cleaned it up, as you can see me do now, and then I even retinned the pins of the original chips with a little bit extra flux and solder. And the result looks brand new. There you are. There, those are the two chips in the middle of the screen. Look at their pins. They have been retinned. Corrosion is eliminated and everything has been cleaned. So that's the final result. Now I want to restore the chips that were on top that have been removed, because I want to use them as reserve chips if they work. So the first thing I did was to straighten the pins. That's what you see me do now. So the pins are pointing the correct directions. And then I also go ahead and retin those pins as well. And that's what you see me do now. I put a flux paste, high quality flux paste on both sides of every pin. On the inner side as well, because that's where most of the corrosion is. And when you activate the flux with the soldering iron, it pulls off the corrosion from the pins. And you have to do that on the inner side as well. Now I use the soldering iron pre-tinned with a 6040 solder. I'm using a solder fumes extractor for my own safety. And when you do that, you activate the flux, you remove the corrosion, and you recoat the pins on both sides with new solder. And those pins will be almost as good as new after it's done. And I clean it up at the end to remove the flux, and that's the end result. Some of the pins are still a little bit crooked. I will correct that afterwards. Now the board is very dirty. Some of the grime you see, part of it, it's the electronics detergent I used, but the stuff glued to it, that's dirt that was there before. There is some cat's hairs there as well, but I'm afraid that's my own fault. I have 3 cats, so cat's hairs are everywhere. Also motivates me to take extra precautions for ESD, because if you pet a cat, your hands get very electric. Those are the chips. I just retinned the pins. There's a bunch of work to do on this board, and I will start by removing all the socketed chips. In the case of the DRAMs, I had to use some more or less specialized chip pullers, because the chips really sink into those sockets. Can't be removed with the chip pullers that you're used to seeing. But I removed them all. Now I'm using a metal brush to clean the rough part of the dirt from the sockets before I use contact cleaner. That's an ESD safe air blower that you saw me use there. That's 2-step contact cleaner. So the sockets are clean now. I'm putting the DRAM chips back, and I forgot to test them. I will have to test them later one by one. I just forgot to do it at this point. This would have been the point to do that. But I'm repopulating the board now. Final clean of the gold-plated legs of one of the ROMs. Putting it back on its socket and continuing with the restoration. So the next step is just a clean, just using ESD safe Kim wipes with IPA. Not only the wipes, but I use cotton buds and those specialized cleaning pads that do not leave lint behind. You use a lot of them. There was a lot of dirt. So now I have to reconstitute the traces that were cut by the previous owner with all the modifications. So the first step is to use a fiberglass pen to remove the solder mask and expose fresh copper underneath. Then I put a little length of copper wire to bridge the gap, a little flux, and then I solder over it. I did clean after this. So I did it several times. This is one of the times. Other times I used just a bodge wire, like now, connecting a pin to one of the available vias on the board. I also cleaned it up after I made this picture. Here's another fix. This was a very short fix, so I could bridge it just with solder without any wire. And even on the top part of the board, I had to bridge some traces that had been cut. I bridged this one with a very thin length of wire and some solder. I cut the excess afterwards and I cleaned it up. Now I recapped the board. Those are the capacitors that have been removed. 2 of them didn't test well on ESR, so it was time to recap this board. So that's being done. And with the board recapped, I measured the resistance across the different power rails. There are 3 of them, and ground. Make sure that there are no short circuits. And you have to wait a little bit for the measurement to become stable, because some of the capacitors charge from the multimeter, so it registers a lower resistance than is actually the case. But everything was fine. There are no shortcuts. So I moved on and changed the multimeter to diode mode to measure the semiconductors. This corner of the board had 5 transistors. I measured the threshold voltage between base and collector and base and emitter for all of them. And the measurements were okay, but they were not quite consistent. I would get a different voltage between base and emitter and base and collector, or a different voltage between different transistors, which are of the same model. So I was, right on the threshold of thinking, should I change it or should I not? They are still okay, but they're not quite uniform. The voltages are not quite uniform. So I decided to pull out the schematics and make sure that I understood the circuit, because I was making these measurements in circuit. So you never know what other paths are connecting the 2 points you're measuring. So after I satisfied myself that I could interpret the results correctly, I did decide to change those transistors just to be on the safe side. I changed them with brand new modern ones, which had a different pinout, so I had to twist the pins around a little bit to fit the old pinout. And I put some shrink wrap on the pins, on the leads, to avoid any chance of any short circuit. So those are the 5 new transistors there, looking funny with those pens. And those are the new capacitors. That's an overview of the board after it's being recapped and cleaned, and the bodges removed, and cut traces reconstituted, and the ROM chip cleaned out with the piggyback thing removed, sockets cleaned. Some of the chips have been retinned. Their pins have been retinned. Brand new transistors on this corner of the board, brand new capacitors. The board is clean. So that's more or less the end result of this first stage of the restoration. Even those little diodes, I measured them. Everything else checks out. I just have to measure all the DRAM chips, which I forgot to do. And beyond that, just turning the computer on will tell if it's working. So this is it for this part 1. I hope you've enjoyed it. Join me for part 2, when I will continue this restoration. It's not done yet. I'm publishing these videos as I go about it, so there may be still some surprises coming, hopefully. Take care, and I'll see you next time.